Welcome to section 8.2, the quadratic formula. More than likely you have heard of it, and if not, don't worry, we'll go over it. One thing, a resource I will be posting in La Lima is the quadratic formula song. It's a fun song that helps you memorize it, so you don't have to be looking it up or writing it down all the time. Okay? Having it memorized makes things way easier, especially on the exam. You will need to have it memorized. It is not given to you on the exam. Okay, so what is the quadratic formula? Well, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It is rather a beast of a formula, which once again, if you want to check out the quadratic formula song, that is actually how I memorized it. I thought it was really helpful. One thing to note, the division goes all the way underneath everything. All these values are right on top of the fraction, and this one is on the bottom, so keep that in mind. And then where are all these values, a, b, and c, coming from? Well, they're coming from the quadratic form, ax squared plus bx plus c equals 0. The a value comes from the item next to the x squared. B comes from the value next to the x, and c is the number without a variable. Those are the ones that you plug into the equation. So let's go ahead and solve example 1, which is solve ax squared plus, that should be bx plus c equals 0. So how would we solve this? Ax squared plus bx plus c equals 0. So we're actually going to not use the quadratic formula. This is going to be proving the quadratic formula. You guys might say, where the heck did this come from? Some weird random magician mathematician plopped it together and now we can solve quadratics? No, there is a reason where it came from, and that's what we're going to do. We're going to figure out where it came from. So I'm going to use the method of completing the square. Kind of like we did before. So let's go ahead and set up for completing the square. We'll subtract c from both sides. So then we have ax squared plus bx equals negative c. And as you recall, we need to have the x squared value by itself, which means we need to divide everything by a. Okay, so then we have x squared plus bx divided by a equals negative c divided by a. And then what else do we need to do when we're completing the square? Yeah, we need to find that perfect number that we can add in to our trinomial. So we'll take our b value, divide it by 2, and then we'll square it. And what do we get when we do that? Well, b over a divided by 2, that's going to be b over 2a squared, which would be b squared over 4a squared. So let's go ahead and add in that perfect number. B squared over 4a squared plus b squared over 4a squared. Once again, remember, we need to add it to both sides because it's an equation. Okay, so remember, we're still following the concept of completing the square. So what do we do when we're completing the square? We'll go ahead and write this as the perfect factored form. Oops, and I erased the other thing a bit too early. That was the item before we squared it. So this is the item that goes inside there. So x plus b over 2a, x plus b over 2a. Once again, remember what we did was we factored the trinomial. We have factored it into these two perfect binomials. So that factored into these two. Since they are exactly the same, what can we do with them? Well, we can write them as x plus b over a, 2a, squared, because they're the exact same thing. So that's going to be, let me bring this down, equals c over, and you know what? Let's go ahead and combine these two fractions while we'll add it. So let's go ahead and build it up. I'll multiply this by 4a. Got to do the top as well because it's the building up property. That'll be 4ca over 4a squared plus b squared over 4a squared equals, so we have b squared minus 4ac all over 4a squared. On that one side, we added those fractions. Once again, what did we do? We built up the fractions and then we added them. Whew, mini break. Okay. We're still solving for x, right? We're following the completing the square concept. So for completing the square, we go ahead and we square root both sides because that's why we made it the perfect square. So we square both sides and we have that plus or minus, very important. And then we have, let's go ahead, cancel those squares, and we get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. Now we can simplify the 4a squared in the bottom. And while we're at it, let's go ahead and minus the b over 2a from both sides. We get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over. And we simplify the 4a squared into 2a. We got rid of that square root. And now what do we have? We have x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And what do you know? These fractions have the same denominators, which means we can add them together. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what do you know? That is the quadratic formula. So now you know it didn't just appear out of thin air. We solved it using one of the methods we learned in the last video. We solved it using completing the square. And that's where the formula came from. All right, kind of fun. Now let's actually use the formula. Example 2, solve 2x squared plus 3x equals 24x. So I may, more than likely on the exam, ask you to write down the formula first. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you might say, why would we use this huge formula if we could just factor it or something? And the answer is sometimes it's not able to be factored. So we need to use other methods. And this is one of the good methods to know how to use. So to use this method, what do we need? Well, we need to know what a, b, and c are. Now you need to be careful here. It's not just which one comes first. A is the value by the x squared, so that'll be 2. B is the value by the what? By the b. Or sorry, by just the x, so that's going to be 3. Now you might be tempted to say, well then c is 20. And the answer to that would be that is wrong. Remember the quadratic formula, I can pull it if it's equal to 0. So I need to go ahead and move that 20 to the other side and set it equal to 0. So once I have it set to equal to 0, then I'm allowed to pull off all my a, b, and c values. So my a was 2, my b was 3, and now we can find c because we had it set to 0. C is negative 20. Okay, so let's go ahead and plug these in. My b values, and my c value, and my a value. Alright, so x equals negative b. I'm just going to go ahead and leave the parentheses and then fill them in a second. Oops, I need to extend that radical there. I would highly suggest using parentheses when you fill this in. Why? Because if you have negatives, it can be a little complicated. So maybe b is 3, 3, and then my a value is 2 and 2, and my c value is negative 20. Okay, so solving, we get x equals negative 3 plus or minus the square root of, well, 3 squared is 9, minus, and we have, let's see, so 4 times 2 is 8, and then 8 times 20 is going to be 160, so that'll be positive 160 divided by 4. Okay, so then x equals negative 3 plus or minus the square root of 169 divided by 4. And I have a feeling 169 is a perfect square number. So let's see, 10 times 10 is 100. And then 20 times 20 is, what would that be? That's going to be 400. So 169 is in between those two. So it's it's either 11 times 11, 12 times 12, 13 times 13, 14 times 14, and so on until we get to 20. It's in between those numbers. It ends in 9. So the only one that would give me a 9 would be 13 times 13, because 3 times 3 would be 9. None of the other numbers on the inside here would give me 9. So more than likely it is 13 times 13. Let's go ahead and multiply that out. 9, 3, 0, 3, 1. Yeah, 169. What do you know? Okay, so that is 13. So square root of 169 is 13 divided by 4. And because all of these are nice perfect numbers, we're going to go ahead and split them. So x equals negative 3 plus 13 divided by 4, or x equals negative 13 minus 13 divided by 4. Once again, we're splitting up that positive or negative, the positive version and the negative version. So then x is going to equal 10 divided by 4, which simplifies into 5 over 2. You can leave the simplified fraction, don't need to do a decimal. And x equals negative 16 divided by 4, which is going to equal negative 4. All right, so there we go. We used the quadratic formula. And that is it for this section. However, one thing to note as you're doing your work, because we are working with a square root in the quadratic formula, it is possible that you could end up with a negative inside the square root. So I'm going to go ahead and write that down. It's possible that you could have a negative inside the square root for this one. And if that's so, then you do not have an answer. The answer is a non-real number. So if you're asked to solve over the imaginary numbers or the complex numbers, you would keep solving and you would be working with I. However, if you're not working with imaginary units, let's say if you're working with a word problem that doesn't require you to use imaginary units, then you would just write imaginary number. That's if you have the negative in the radical. Another thing to note, besides having a negative in the radical, sometimes in your radical you might end up with 0, which means you would just have one answer. However, if in your radical you end up with a nice positive number, then you'll end up with the two answers like we did before. So once again, there are 3 different answers you could get. You could get an imaginary answer, you could get one answer because you have 0 in the radical, or you could get 2 answers like we did for this problem. Alright, that is it for this section. Once again, if you have any questions or concerns on the lecture notes or the homework, please reach out to me. Communication is important. And feel free to stop by my office hour or set up time for us to go over any of these in another time during the week.